Alright, this week we worked on weighted averages. Students will use weighted averages to locate points on a number line and on a coordinate plane. Our main concept was that if we had a point A and a point B, they have locations, they're also going to be given some importance, some weight, which we normally call W. If we want to find the weighted average of those 2 points, of point A and point B, all we're going to do is multiply A times its weight and B times its weight, add them together, and divide by the sum of the weights. Our standard practice is going to be just doing the weight of a point times the value of the point, or the location, and repeating that as needed. Divided by the sum of the weights. And here we see it with 2 coordinates, A and B. We could do the exact same thing with 3. It'd be weight times the point of A, plus weight times the point of B, plus the weight times the point of another point C. We're going to take a look at example 1, A and B, and we'll take a look at example 2A. Example 1A here, we're asked to find the weighted average on a number line. We're going to find a coordinate P that represents the weighted average for this given sentence. Point C weighs twice as much as point D. We're not told how much either point weighs, so we get to make a choice. We're going to set one of these points to weigh 1. It doesn't matter which one you choose in the long run, but it's easier to choose point D, in this case, as having a weight of 1. And since C weighs twice as much, we get to say C has a weight of 2. With this information, I'm just going to put those values over their points on the number line. So the weight of 2, the weight of C, which is 2, I'm just placing over C. The weight of D, which is 1, I'm placing over D. And we're following the pattern of just doing the weight times its point plus the weight times its point. We're going to do the weight of C times the location of C. And then we're going to add the weight times the point of the other coordinate. D has a weight of 1, and it's at a location of 2. We're going to take this, we're going to evaluate it in a second, but we also want to make sure we're dividing by the sum of the weights. We've got a weight of 2 and a weight of 1, so I'm going to show that I'm adding 2 and 1. I'll multiply these, I'll get negative 6. I'll multiply these, I'll get 2. Negative 6 plus 2 will be negative 4 over 3. Negative 4/3 would be the weighted average between C and D. We did this with 2 coordinates, C and D. We could extend this to 3. Point G weighs 3 times as much as point F, and point H weighs twice as much as point F. We don't know how much any individual point weighs, so we're going to make a choice. We're going to make one of them have a weight of 1. G is going to weigh 3 times as much as F. H is going to weigh twice as much as F. Sounds like it's going to be easy to make F have a weight of 1. So I'll put the weight of F as 1. Point H weighs twice as much. So point H will have a weight of 2. Point G weighs 3 times as much as F, so it has a weight of 3. We again are going to place these numbers over their points on the number line. G has a weight of 3, so I'm going to place a 3 over the G. F has a weight of 1, so I'm placing a 1 over the F. H has a weight of 2, so I'm placing a 2 over the H. We're doing point, the weight times the point, plus the weight times the point, plus the weight times the point. We're just multiplying straight down and adding our answers from each of the multiplications. The weight of 1 times the location at -1. The weight of 3 times the location at 2. The weight of 2 times the location of 6. We're going to divide this by the sum of the weights. So 1 plus 3 plus 2. We'll get -1 plus 6 is 5 plus 12 is 17 over 6. That would be our coordinate on the number line where we could balance these 3 points with those given weights. 17 over 6, that's nearly 3. So it'd be like right there on the number line if we wanted to place a balance there, or if we wanted to balance the number line on our finger, that would be the spot to balance it so that one side stays the same as the other side. We've just done this one dimension. We've done this just on the x-axis. The last thing to do is do it in 2 dimensions to find weights on the coordinate plane. It's just the same process twice. Whatever we did earlier, what we did earlier on the values for the x-axis, we're going to do it twice. We're going to do it once for the x's, once for the y's. Let's see this super quickly. So, they mentioned point D has a weight that is twice as much as E. Well, I'm going to make it an easy choice. E is going to have a weight of 1, so that D can weigh 2. Have a weight of 2. I'm going to place these values on my actual picture just to help me visualize it. D has a weight of 2, so I'm going to put a 2 over the coordinates for D. E has a weight of 1, so I'm going to put a 1 over the coordinates of E. And we're going to do the process we did here on example 1, A and B. We're going to do it once for the x and once for the y. Let's do it for the x first. For the x's, we're going to be multiplying the weight, which is 2, times the x, which is -4. And we're going to multiply the 1 times the 2. 2 times -4 plus 1 times 2. All over, add up the weights. 2 plus 1. Then we just need to evaluate, plug in some numbers. 2 times -4, -8, plus 2 is -6. -6 over 3, we get to simplify that to just a -2. That would be our answer for the x values. We would want to repeat the process for the y's. So now, we're going to do the y's. We're going to do 2 times 2. We're going to do 1 times -2. We're going to be multiplying the weight times the y coordinate. Two times 2 plus 1 times -2. All over again, the sum of our weights, 2 plus 1. We get 4 plus a negative 2 is 2 over 3. I can't divide this, I can't simplify this fraction, so I'll leave it as a fraction here. The point P that we'd be looking for has the coordinates of negative 2 and 2/3. Its x is negative 2, its y is 2/3. If we look on our graph, we can see the point located on our line here. When you're finding the weighted average of points on the same line, the weighted average should be between the two coordinates, between D and E. Notice that we did not use F here in our problem, and we didn't because F was not mentioned for D and E. We would only use point F if it was mentioned in our problem statement here. We had 5 homework problems to do related to this that plenty of you did in class 1, 2, and 3. Question 4 and question 7. That was your homework. I'll record another video with the Now You Tries.